I'll proceed in English if that's okay. Yeah. Yeah. Okay. Good for Jurgen. So I'm going to be talking about web services for the industrial Internet of Things, and this is going to be a new LonMark standard, and I'll talk more about that. So our vision for the industrial Internet of Things is that we believe there's a great opportunity to unleash the data that's already out there in existing networks and hundreds of millions of devices, and bridge that data to the future. So the way we do that is first we embrace the data. We embrace the systems that are out there. We embrace the protocols that are out there, LON protocol, BACnet protocol, Modbus protocol, MBus protocol. There's millions of those devices out there, and so we need to embrace those devices and bring their data in. But then we want to extend. There's new kinds of protocols coming out, and I believe Jörg probably spoke about some of the newer protocols coming out, new cellular kinds of protocols or Bluetooth low energy. So we want to extend to new protocols in the future and have a platform that can go from today's protocols to tomorrow's and support them all. But then we want to enhance those systems, right? You want to take data from all these systems and bring it to the cloud into new IoT services, for example, for doing data analytics or for doing artificial intelligence. And so what we want to do is bring all that together. And the way we bring it all together is with a common protocol, a common web services protocol, and that's what we'll talk about today. So that protocol we call the IoT Access Protocol, or IAP. So it's a very rich web services standard, and I'll describe how it's rich for both edge and cloud applications. And the purpose of the protocol is to create APIs that developers can use to create applications that can access data in any kind of device, whether it's an existing LON device or a Modbus device, and get that data from the device, but also be able to provision and maintain those devices because they have to get installed into a network, monitor and manage alarms for the devices so that you can be alerted of error conditions within a system, and set and manage schedules. And the applications that use these APIs can run in a variety of places. They can run right within a web browser because they're very lightweight, built to run from a web browser. And so you can create an application, say that's within a web page that interacts with the API, but also can run as a service, for example, in a cloud application. And that's where you could create a service, for example, to do data analytics or to do artificial intelligence, to do these new kinds of IoT services that are becoming available. Or finally, you can host them right within an edge server. So you have an edge server sitting at the edge of the network. You can run these services that use this API within the edge server. And we'll have two forms of the API available, one that uses REST, one that uses MQTT. I'll talk a little bit more about that. So here's the first, is the MQTT-based API. And the idea of MQTT is a very modern, lightweight IoT protocol that's very good for doing a publish-subscribe interface where any device can publish information, whether it's a piece of temperature information or motion information, and other devices can subscribe to that information. So a device can say, I'm interested in monitoring the temperature at this point. And so MQTT creates that connection between the publisher and the subscriber. And any device can subscribe to any topic. And other technologies that are very similar in idea is what LON has done with network variables. Network variables were a way for a device to publish information to another device through a connection that the other device could receive. And so we kind of take that same idea and move it to the IoT. Twitter, of course, does the same thing. Anyone can publish a tweet in Twitter, and anyone can subscribe to those tweets. Whoops. And the beauty of the approach is it's inherently multi-protocol. Right, so here's IAP-MQ. So this is the open protocol for MQTT. I can have different protocol translators that translate from MQTT to other protocols. So for example, that top one might be LON-based lighting controllers. The bottom one might be Modbus-based motion sensors. And just by having two simple translators and engines, I can interface with all those devices. So those gateways can create the abstractions of those different kinds of devices and bring them up into the cloud services that you're connecting to. But even more interesting is now we can create connections between devices, even devices that are on different networks. So for example, if that's a Modbus sensor and that's a lawn lighting control, I could create a connection so that when that motion sensor goes off, the light turns on. And that can happen even across media, even across protocol, even across edge servers. So I may have this on one edge server, I may have that on another edge server. I could create connections between them. So you have very responsive systems with peer-to-peer connections so that you can have the instant response that you want when something like a motion event occurs and you want the lights to turn on. But we're not just about data, we're also about services. Services are very critical in many IoT systems. So services are things like scheduling, where you want something to happen based on time of day or based on sunrise or sunset relative events. Logging is very critical. You want to collect the data from all these sensors and keep it over time so you can do trend analysis, for example, of energy usage over time. And finally, alarming. You want to be able to monitor the data for any kind of air condition. Does it get too hot? Has the light failed? And so alarming is also a standard service. So these are all standard services with standard APIs so that applications can be built, for example, to do scheduling or logging or alarming. And you can combine all these things together, right? So we can have an edge server with these services. So here we have the built-in services. Here we have the gateways to other protocols. And then we could connect out of the edge server to talk to the cloud services or other edge servers. And so there's a message broker running here that's connecting all these things in the edge server to the external services that need them. And by doing this, we can also then support an external central management system, right? So a central management system is a piece of software that you use to create the network, to monitor the network, to control the network. So that central management system has its own broker. It connects into the same bus. So here I have two edge servers doing the same thing I just described, talking to a central management system that's using the same MQTT interface. And you may have more than one of these, right? So we have one common message bus that can scale from many edge servers and many cloud services. And once you're in the cloud, now this cloud service has visibility into lots of sites. There may be hundreds of sites out there, thousands of sites. And I could connect to that same message bus from that cloud service to other services like a data analytics application or an AI application that's going to do some kind of predictive monitoring of the system. And we believe that's going to create major new opportunities for vendors to create new kinds of systems that have new kinds of capabilities that aren't available today, and creates a revenue opportunity for the integrators who can put those systems in. And again, this is one common set of APIs. So here I have an edge server with its bus inside the edge server, maintaining data, maybe serving up a user interface for that system. But you can create applications that run within the edge server. That's the green ball. Those applications and services are using the same API. But I could connect that bus to a bus in the cloud. The bus in the cloud can have its own sets of services that are communicating, again, over the same message bus. And by connecting the two, I have one common message bus where everything in the edge server is connected to everything in the cloud. And I can create custom applications that talk to the cloud. But those are using the same API. So by using one API, I can have one application that can either run remotely through a cloud service or locally directly from the edge server. And so this kind of shows the great opportunity that we're creating for vendors to create edge servers that have these services built into the edge server, that have drivers for all the existing protocols that can be expanded to other protocols in the future, can have a user interface built into the box, and have a box that's very extensible where you can add new services to it. And they can connect into cloud services that in turn connect to other sorts of services like data analytics and AI. And do that all for many existing protocols, whether it's LAN or Modbus or BACnet, and add the new ones in the future. So the benefits of this protocol that I've described is that it's open. We have an open specification that we're working with LonMark to standardize. Very lightweight, so it's suitable to put into a very small IoT device, or you can put it into the cloud. It's very simple. The publish-subscribe model used by MQTT is a very easy-to-use model for developers to create these sorts of services. It's very fast. You have simple processing in both the client and server. Event-driven, so when you have something like a motion detector controlling lights, it can be very fast. Very flexible, since it can run anywhere, either in the edge device or in the cloud. It's web-centric, since we are based on standard web standards like MQTT and REST. Secure, which is very important, using TLS encryption. Compatible, since it's supported by all programming languages and scripting languages. So for more information on OpenIAP, come see us. So we're right here in the booth, right here in the corner, which is D60. We also have a lighting demonstration in Hall 5, D29. You can come talk to me in the booth, or you can email me at rich@echelon.com. So thank you very much for attending. Any questions before we go? No? Okay, well, I'll be right over here, so come on by. Thank you.